Thank you. Thank you, organizers, for giving me this opportunity to be the chair for this session. I'll be brief. It's already 5:45. I know all of you would be wanting to go back. You have to come back tomorrow as well early. Session today, innovative applications of generative AI in actuarial data science, being dealt by Satya and Rohan Yashraj. Needs no introduction. I'm sure all of you know them. They're from SSSIHL, Sri Satya Institute of Higher Learning, a premier institute which has a center of excellence, generating a lot of quality actuarial students, both from the actuarial perspective, but also from the tech perspective. They would speak more about the applications. I won't get into it, but I just wanted to give some flavor as the chair. I'm sure you are aware of NHA. We have heard about it even today morning, the National Health Authority of India. Today in Delhi, they're signing an MOU. The government of Delhi is signing an MOU with NHA for extending the Ayushman Bharat for the Delhi people. There is some connect, so I'll leave it over there. You know Gen AI, I don't have to brief it. But it has a lot of connection with fraud detection. Yash has done a PhD in fraud detection. So I'm sure you would hear and know more about that from him. But recently, as you are aware, we have a huge insurance scam on the life insurance side, where, it's a multi-crore scam where, the dead people have been insured and been scammed from the insurance companies. They'll talk more about data. They'll talk more about how they can train the data, be it from own data source, historical sources, or else a synthetic data. They'll talk about the machine learning. They'll talk about the various models. They'll also talk how it can be applied, the Gen AI can be applied for various insurance related applications. Without much ado, I'll give it to both Satya and Rohan. Please. Thank you.
Imagine a world where actuaries don't just predict risk, but actively generate data to refine their models. A world where AI helps us detect fraud before it happens, price risks more effectively, and enhance reserving techniques. That's the power of generative AI. And today, we'll explore how it's transforming our world. Good evening, everyone. It's with absolute pleasure that I'm given this opportunity to address all of you on this topic. Today, we'll take you through a fascinating application of generative AI in actuarial work with a focus on Ayushman Bharat, which is India's largest health insurance scheme. So we will cover various aspects. We will start by briefing you about what generative AI is and its evolving role in the area of actuarial science. Talk you through a case study on Ayushman Bharat fraud detection. Then a generative AI model and its integration with fraud detection application which we have developed. We'll be demoing that. Then talk you through various use cases of Gen AI in actual work. Then end with ethical considerations that we need to take into consideration whenever we are using such models. And end with the future of actual work in the area of generative AI. When we think of AI, we often imagine it as a tool for analyzing past and predicting outcomes. But what if AI could actually create something? What if it could actually create insights like we had never seen before? That's where generative AI comes into picture. We have been exposed to generative AI back in the year 2022 when ChatGPT was made public. That was the time when the public really got to know about AI and we started having discussions around generative AI and so on. Since then, lots have changed. Just in the span of 2.5 years, we started with generative AI using ChatGPT. Then in the year 2023, 2024, there was another revolution which came in this field when co-pilots was introduced, which revolutionized the way developers would code. It would help developers assist in their coding. And today, in 2025, we are talking about AI agents. But we will take baby steps in this area, and we will go from the basics, probably starting with the integration of ChatGPT, because as an actual field, there's still so much to catch. Unlike traditional AI, which mainly classifies or predict, generative AI helps us create new content, whether be it texts, whether be it images, whether be it creating videos, or creating simulations, or even actuarial insights. At its core, generative AI is powered by deep learning based models, such as large language models and neural network, which learns from vast amount of data to generate realistic outputs.
So we have seen currently like the traditional actual methods of GLM, credibility theory, reserving triangles. These are the traditional ways of arriving at our outcomes in actual field. But challenges are there with these things, particularly data scarcity, manual processing, complexity, and there is a great need for automation and enhanced insights are required. So those are the challenges actually which push us to really look at what is available and what's the new or innovation that others are, it came up and others are using. So if we look at what is transforming other businesses, because not just the insurance world, other world is actually moving a little faster in adopting the generative AI. So this is where we see the automation of repetitive tasks. So there are, the automation of repetitive tasks are there already in the past, but like automating that whole thing of automation is the one actually which is we are getting as part of the generative AI. So where we see greater impact in many businesses. So few of them are being used in insurance, but like for now, we see the greater application of automation of repetitive tasks happening in every place, including the language departments in the universities. You name it, you find greater efficiency is coming up with respect to this. Then enhanced decision making, where actually AI provides greater insights than what we normally see. So this is where we are seeing the decision making is becoming more and more very productive in this situation. Then personalization, while the entire thing is happening, you have personalization which comes into the whole activity of the decision making, and very specific to pricing and other services which we are doing. So this is where the generative AI is transforming the business. The innovation and creativity, it is actually, instead of working on the lower end activities, tasks, it allows us to really work at a higher level where you can look at actually how to really make the creative part of the, so if you look at last few months, one type of LLM model comes, then again after a few weeks another model came, then with improved features, then again another one. So this is where you see greater creativity, greater innovation, and which is becoming available for everyone to really use it and then take it forward.
Just to give you an example, right, on the hyper-personalization, we are already familiar with services like Netflix, YouTube, Amazon Prime Videos. All of that is a great example of how generative AI is being used. We just watch one content or a couple of contents, and then next day we see all of the recommendations similar to our likings coming into picture, right? And talking about innovation and creativity, Google's DeepMind research team is working on a very revolutionary thing on drug discovery and related content. So yeah, so the point being, AI is being used across various businesses, be it finance to healthcare, across all the industries we are seeing it. But what about insurance, right? Insurance is built on data, whether it's pricing, claims, or underwriting. But with AI's ability to generate greater insights, the industry is undergoing a major transformation. So a couple of examples being, AI can be used on automated claims processing. AI can help detect fraud, automate settlements, and even analyze accident images to estimate damages. Then AI can be used on underwriting. AI-driven underwriting is another thing which we see across the internet, where insurers are using AI to assess risks faster and more accurately. Then dynamic pricing and telematics. So usage-based insurance is another thing which is booming. So which is another area where AI is being used. Then reserving and capital modeling, where AI-enhanced simulation helps insurer predict future claims and manage capital more effectively.
See, going through thousands of pages to determine whether to pay or not, or how much to pay, all those things actually used to take a huge effort, and then with accuracy we were not able to do. So this is being used in other industries, and then more it is useful in insurance industry. Also when we work as actuaries, we work with other professionals. When others are using, again, if we are not up to the level, then there is a gap actually which we may not be able to bridge. So as a group, when decision making is being done, this is where the insurance industry needs to adopt the newer things which are coming in our way, and then use it as a collective decision making along with other professions. So as we move forward, we look into that. So this is all theory, little bit. So we just want to show you a particular way of how we implemented this particular thing. This is related to Ayushman Bharat. This is world's largest group health insurance scheme. So it's a huge one. So we are talking about 66.7 crore health accounts created. It's about 40,000 hospitals are empaneled. Then 90,204 crores was paid. Then it covers 1,393 packages, means different surgeries and packages. So it's a huge one we are talking about. So here it gives a great opportunity for us to really dig into this and then find out how we can actually use generative AI in this scenario, and then the outcome of this will really give you a good opportunity to use something similar in pricing, claims, and many other areas. So this is one example we want to show with a demo.
So till date, we have been working on numerous works around using machine learning and deep learning models for building fraud detection models, right? But one of the challenge which we have always faced is, now let's say we come up with a machine learning model, have deployed it nicely, we have an application for it, but in order to use that application, right? So as a user, we come up with our requirements, right? We come up with a set of claims, let's say, and then that needs to be run through the application which we have built. So, but before the user goes to using this application, they have to first reach out to the data science expert who understands how to use this model, right? So because the model is trained to synthesize information in a specific way. Let's say a model was built on a data set which requires 90 features, for example. The data has to be parsed, has to be processed in a way so that the model can understand. If the data is not provided in that fashion, the model will fail to process it. So that's where we saw a big area where improvement can happen. And this work, the idea for this came from the proposal by Casualty Actuarial Society, which encouraged, I guess was about 2.5 or 3 months back, which they had sent this proposal, wherein the entire idea behind this proposal was to encourage actuaries to find innovative ways of using large language models into their applications, whatever they have been building. So that's where we thought, how about we enhance what actual data science experts are doing with integrating large language models here. So what it essentially does is, we as users, we are still doing the same thing. We are going and interacting with the models which we have developed, but rather than going to the data science expert, we are now interacting through an interface which is built on a large language model. So the benefit of this is, we have seen, right, over the last 2.5 years, that the large language models are so good, we just, in a very crooked fashion, we just express the idea which we want to generate, and the LLMs are so intelligent that it's able to create, recreate with better ideas, all of that information, right? So why can't we leverage that aspect of LLM? So with that idea in mind, we had created this application. So the application does exactly like what we have told. So we go as a user, we go with our set of data. It could be in an Excel format, it could be in a picture format, it could be a picture of a, let's say, hospital prescription, it could be an image of a, you know, an operation which has happened, or anything, whatever be the information. So based on all of that information, the large language models can be coded to synthesize all of that information, to then further pass it to the to the machine learning model which is sitting at the back end to do the further analysis. And another great advantage of using such model is that the model can create insights which the experts, the data science experts, might not have that much understanding to create insights. So that's another thing which we'll be demoing it to you now. So let me just take a couple of seconds to navigate to that screen. Yeah, so this is how the interface looks like. So it looks exactly like how we are used to seeing all of the large language models. So it gives, it lands on a home page which gives you a couple of options. So currently it's in an experimental stage, but the idea can very well be depicted with this application. So we have features like analyzing new claims or verifying hospitals or compare treatment costs or pattern analysis. Let's say analyze new claim is what we want to do. So we click on this. Hopefully the internet is strong enough for it to run. Yeah, so the moment we click on analyze new claims, so the system generates a prompt saying that I want to analyze a new claim for potential fraud. Please guide me through the required information. So the chat replies back to you saying that these are the information which is required to be provided for us to perform any further analysis. Now let's say I just want to see how the model is working, right? So I just give a prompt saying that, okay, give me some example with high fraud score, right? Let's see what the model does. So model generates the data because we just want to see how the model is working, right? So it's all in an experimental stage. We are just trying to see the potential of large language model in incorporating into our current workflow. So the model has generated some data. It has all of the information on the claims, on the policyholder level information, hospital level information, then treatment information. Now let's analyze the claim. So the model is going beyond this, right? So the model is taking this as an information and it's doing its own analysis. So it finds that geographic anomaly is there because we asked the data to create a fraudulent data. So all of the fraudulent characteristics is what is replicated in the generated data. So it found that there is a geographic anomaly. The patient traveled a significant distance from the resident to the hospital, which is unusual, unless the required treatment is unavailable nearby. So it raises a suspicion, right? So something similar to what we would do otherwise whenever we are trying to build a fraud detection model. So which now LLMs are able to interpret all of that. Multiple claims, it finds that this is also something which raises suspicion. Then unnecessary procedure, inflated billing. So based on this factor, this claim would likely receive a high score between 0.7 to 1, right? Indicating that immediate review is needed. So it already raises an alert and it happens so quick, right? So I didn't have to format the data. I didn't have to do anything. The format, so once the model is developed into its full capacity, we can have the model working the way we currently interact with ChatGPT. So that's one of the beauties of working with such model, right? So I'm also happy to share with you that the model is now hosted online. So I would encourage all of you to scan the QR code. So it would redirect to you to a URL called SSSInspires.com, which is hosted in our private network. You can, so the landing page would take you to a sign up page. You can register with your email ID and password and start exploring and testing out this particular model.
So while this is on, just one thing is, we can also ask the model to explain us how it is working. So we can, that entire thing actually it gives, this is how actually I'm analyzing the entire data, and based on this particular rule, this is where we are arriving. So that actually you know precisely what rules are being applied at the back end, and then how we are arriving at the fraud score of 7 to 10 or whatever. So while that explains the reasons in general English, it also gives the technical background of how this entire model is working behind the scenes. That is where actually the power of this generative AI application. So here we are using the data which is actually synthesized data. Again, because that helps us to avoid bias. But to understand a little bit about the fraud detection, how it works, because there is a whole lot of background for this. So this is the third session we are doing. The very first session we did on machine learning models for fraud detection in health. Later we worked on, that was actually with the CAS, the project. Then the other one we worked on interpretable machine learning models, that is again with the Society of Actuaries funded project. Then we came to generative AI. This is the one which is actually very useful directly. The way, so if we know how to make use of this powerful tool, it's not just fraud detection we are talking about. You can go very deep into pricing, reserving, capital modeling, many other areas. So this is one good example that we thought we provide to you. So, and if you need any help with this QR code, the volunteers, they can help you to get if you can catch it directly from here, it's good. So going forward with this.
Yeah, so we have another 20 to 25 slides basically detailing the model which is running at the backend, but at the risk of not bombarding all of you with all of the technical difficulties, what we'll do is we'll just skim through all of the information, because the workflow which we are following is the general data science workflow, but we'll just skim through the information, and all of the information is there in the slide for you to refer, and if there's any question which you might have, we can always take it up on that later.
It's basically reference material to prove the model is working on a scientific basis. So that's where I can, and with the data that we use. So this is the data science workflow that we adopted, like data pre-processing, feature engineering, synthetic data generation, training and testing. This is what actually we did. So as we move forward, the challenges that we faced initially when we were doing in other ways, because it's a very traditional way. It takes a lot of effort, and then we may end up in wrong desired outcome may not be coming with a proper rating for the fraud. So that's where actually many things we had to overcome. Then the impact of actual modeling enhances basically benefits of synthetic data. And there are challenges also. So we have taken both of them into consideration while building the model. Then we did the exploration of the data and exploratory data analysis. In this, we looked at various things. Then these are the graphs as an outcome of this heat map. Then we looked at outliers. Then we actually looked at the distribution of various features. Then we looked at actually one of the most important thing in fraud detection is data imbalance.
Yeah, so this is another area where we also used generative AI models, right? So imbalance dataset is one of the key challenges whenever we are working with fraud detection models. So handling data imbalance is done using various models. One of the commonly used models is SMOT, but one thing which I would like to draw your attention to is that we have also used generative AI model here. So models like variational autoencoders, generative adversarial networks is something which we have also used for creating synthetic data. So there are methods of testing whether this synthetic data is reliable or not, which is what we have done, and ultimately tested the balanced data set across 3 different models. One is on random forest, then on XGBoost and TabNets. So and across all of these models, so now what we have found is over and over after testing through multiple models, what we have found is the models have become so good nowadays that if you have sufficient data, getting 90 to 95% accuracy is really not a big deal, right? So now things are coming into how well can we create greater insights, how well can we explain these models. So these are the topics which we are trying to address now. So again, we have other types of insights which you get whenever we are trying to use these models. So things like feature importance, right? So how did we use this information is for us to finally come up with those set of 15 or 16 different features which the chat bot is asking us, right? So how did we come up with those 15, 16 features? So feature importance analysis is one way of coming to that, and all of the outcome that we have got is what finally culminated to the application that we have built. Then the results and impact. So generative AI's advantage in fraud detection is tremendous. So it can help evolve very fast with the changing fraud pattern. Then it also helps reduce fraud, false positives in our predictions. The challenges are many, so high computing cost is something which we have to deal with whenever we are trying to do real-time fraud detection, and there are legal and ethical considerations we need to keep in mind. So there is yet another application of AI. So fraud detection was one application which we showcased, but there are various other avenues where we can see the use of generative AI. Pricing is one such area. Then there are multiple ways in which we can use pricing. So one of the ideas which we have put it on the slides here is how about using things like conditional GANs, right? Where this could help us generate policyholders cohorts with specific risk attributes, wherein we don't have so much of data. How about using such models to generate those synthetic information which would help us price these lives better? Then there are again benefits and challenges which we need to take into consideration. And there are again, apart from pricing and fraud detection, there are various other areas wherein we are actually seeing organizations using these Gen AI models.
So it's no longer theoretical because there are organizations which are using this. So here our intention is to bring it to the actuarial community that this is something which you can use it for various aspects of the actuarial work. So fraud detection itself is a complex thing. That's where actually got his PhD. So there is a data imbalance. That itself is a huge area of how we really bring both the things together. So the various other examples we have in like the PwC's AI reserving tool, Prudential Sharp-based AI model. These are the real ones which are actually being used in different places in the world. So as we move forward, again, this black box problem which is actually there, that is where the regulatory aspects come into picture.
So we should be able to explain these models, right? So there are frameworks for it, so which we had also presented in the previous slide, previous sessions. And this is the work which we also have published in the Society of Actuaries research article. So you can have a look at that. And the impact of model interpretability is again many. So one thing is it helps build trust with regulators. If you are able to explain the models the way they are working, it helps in building trust. It ensures that there is a fairness in AI-based decisions. And again, there are challenges, right? With everything, there is a challenge. So here the challenge is the trade-off between interpretability and complexity. The more complex the model is, there is a high likelihood that you will find it difficulty in explaining these models. And challenges and ethical considerations. So there is a data bias and fairness which we need to keep in mind, right? So generative AI is trained on historical data which may contain inherent biases, right? So we need to keep that at the back of our mind, and whenever we are using such models to create synthetic data, so there is a very high likelihood that the created data also might have some inherent biases. So we need to keep these things in mind. Then there are some regulatory and compliance challenges which we may have to overcome. And there is transparency and explainability issue which we need to keep at the back of our mind. So future of generative AI in actuarial science, right? So AI will act as a co-pilot. That's what we feel, right? So assisting actuaries in analyzing complex data faster and with greater accuracy. Actuaries will need new skills to work alongside AI models, right? So it's no longer, no longer AI is just a thing for data scientists. AI is now becoming a tool with every passing day. So we need to keep that in mind. So it's becoming a new skill for actuaries. Then there is an expansion which is happening on newer domains. So we are talking about things like parametric insurance, embedded insurance, climate risks, and ESG modeling. So these are all of the various avenues where we see the future. So as a final thought before we end this session here, so what we would like to say is generative AI will not replace actuaries, right? So we are not saying that it's going to replace actuaries, but it will definitely enhance their capability by enabling faster, deeper, and more efficient risk analysis. The actuarial profession must adapt and embrace AI rapidly, ensuring that innovation aligns with regulatory and ethical best practices. With that, we would like to end the session. And thank you all.
Thank you, Sai, and thank you, Rohan, for such a wonderful and inspiring presentation. Given the time, I'll open it for questions. maybe 5-10 minutes. Since this is the last session, I do have a free hand. Nobody's waiting for me. Yeah, please. Do you have a mic? Can somebody help them with the mic?
Was there fairness or ethical concern that you came across while generating the synthetic data for this activity?
Means we are actually looking into this aspect. So currently this is not made public. I mean, this is not made like a product which companies can use now, right? So it's currently in an experimental stage, as we are telling, but we are keeping a note on that. So we are putting places, means we are putting conditions within the chat GPT model to ensure that any private information is not leaked, or any of such informations are not passed by the model. But yeah, that's a very valid point. We are keeping that into our minds.
This is for fraud detection, but like when we start using it for underwriting, that's where most of the considerations come into play. But the model has the capacity to put all those conditions in place, where actually we make a note. These are the things like gender, we are not allowed to do, or even some other considerations like smoking or any other thing. So that capability is there in the model, so which we can actually adopt inside the thing. So that's how actually we are managing the ethical consideration.
Thank you. It was an amazing session.
In Actuary, it is a new picking space. So I have a very basic question regarding when the implementation of this fraud model will come in. In India, we have seen there are certain groups which are committed to commit fraud, right? And in every 6 months, once your model has detected that these are the certain characteristics which comes into this fraud detection, they will change the nature of fraud, right? And as you said, there are certain computing challenges, there are certain factors which is taken as a basis to detect those frauds, right? So how easy it will be to change those parameters on a timely basis, like in 6 months or a year? Because me being a fraudster, once I know that my action has been detected as a fraud, I'll change my action, right? So how likely, how easy will that be to change the model? I personally don't know much about how AI is being used. I would like to know from you, what is your understanding on that, so that whenever the application comes in, we'll be able to make it we will be able to make it usable for the wide audience and for the government. Since we are talking about Ayushman Bharat, we have seen 19,000 crore has already been paid off, right? Many more lakhs of crore will be going to be paid off. So single saving of money will be like 1,000 crores, I would say. So I just wanted your insights on that,
Just
please.
little first part, I say repetitive act. Slowly our interest will come down, actually our performance will go off. Whereas for the machine, particularly this type of thing, more and more it does, more and more it learns, and more accurate it becomes actually. Not only accurate, there are multiple specificity, F1 score, like we look at actually many other things. So machines actually, they become more perfect when actually involved in this. But when it comes to newer things, the way so newer insights is what we are getting by doing that. So if you see, the generative AI is really helping humans to get away from the repetitive activities. That is why we really need to adopt that, because that is actually something allowing us to focus on something very higher level, because that's why actually we are able to create something LLM model by humans only. Because if we are burdened with the same repetitive activity, we would not have gone there. Now that we have gone there, it's in our interest actually, we need to make this machine more sophisticated. So that is where I see as the insights which are coming out, even like the QR code is given, you please try. It really gives greater insights why a particular thing we are saying a more fraudulent potential case, like the rating. So this is where the newer type of fraud, yeah, machine has to learn, that is there. But prior to that, it may provide some insight, because there is when we are building the fraud detection model, it's a very complex one actually. Among all other things, fraud detection model really complex because of the data imbalance. Also, you may not know what is the final truth, because nobody knows actually finally how many claims were fraud, how many were not fraud. So you don't have a real data where actually you can refer to. So when it comes to these type of things, the way actually we look at is the model can improve by providing its own insights which humanly not possible. Then, but when we find out one, definitely machine can help us to really look at all possible combinations around that so that we'll be able to help the customer in a better way. But I'll leave it to Rohan first.
Yeah, so from the technical perspective, right, so how long would it take for us to update the model? So actually it depends on the architecture, correct? So it depends on the architecture of your model behind creating these applications. So I would like to give you an example of some of the giants, right, in the market. So when we talk about things like YouTube or Netflix, right? So we have seen that over the years, their recommendation engines have become so good. But hardly do I remember when was the last time YouTube went down or when was the last time Netflix went down, right? Because their architectures are so good. So that's where I see, when you really see from the technical perspective, when we talk about how fast can we improve this model, it ultimately boils down to your architecture, how good your architecture is. And if you have a very good architecture at the back end, we can be working and improving the model at the back end with, with visibly no downtime at all. So that's what I'd like to add there.
Any further questions? I do have a question. Yeah. So what it takes to build such a app or model, whatever you call, through using the LLM, be it on the cost, be it on the resources or the curriculum, what do we do as actuaries individually, but also the institute collectively to build the future Aravind Srinivas or perplexities from our community?
So it's a very important one for actuarial profession because it's there already. So how we use it, it matters. So it needs to be part of the curriculum. So how it can happen, it need not be examination, one more examination, it will become burden. So, but it can become part of the base subjects where these type of concepts are provided to as a foundation. And because tomorrow we have Gen AI in one particular level, then it may really get to the next level where the whole thing may transform. The generative AI, the way we are seeing, that itself may get transformed because we have seen so much transformation. So the foundation that we have in actuarial subjects, if we can include the foundations which are actually leading to the generative AI innovation, that will help immensely. That is one. Then the other thing is the aspect of currently, like say if we see generations of actuaries are there. So we have like if we say like there are 4-5 generations we call, like they 200 years old, then after that 100 years old, then general insurance coming into actuarial field. That itself is a major thing. Then after that data science came in. Now generative AI. So adopting that very, very important. So for our purpose. So do we lose our jobs if we don't pick up? No, nothing like that. But like we may end up doing repetitive jobs which are not required. So this is where actually we can, if we learn this, we can actually get into other fields where it may improve our situation and we can be on par with other professions. But I want Dr. Rohan to add.
Yeah, I guess very briefly, right? So when we talk about the cost of implementing such models, so I would say it's pay as you go, right? Whenever we are using models like LLMs and all, so it's literally pay as you go. So the more you use, the more you pay for it, right? So and then you can find it on the internet, various tables, and it depends on the organization from where you are using this API from. If you are using an OpenAI, then OpenAI has its own set of prices. Anthropic has its own set of prices. Google has certain things which is freely available, which is what I have used here. Google's Gemini provides Gemini 2.0 Flash, which is free to use for developers. So yeah, it ultimately boils down to our use and how much we are using.
See, it's between training data scientists into actuarial and actuarial experts into data science. You may find the training actuaries in data science may be very helpful in our world. For other industries, it may work very differently. But like we are in actuarial profession, hiring a data scientist to do actuarial work may really take a long time, and then it's an uphill task. The other way around may work, so, but we can actually split the actuarial work very separately and work together. So that is where many companies have seen great success. But I would like to know your point of view.
No, I completely agree with you. We'll have to integrate. As you know, as you can see, our horizons are also expanding. Yeah, yeah. So yeah, we will definitely look forward to integrating our curriculum. I'm sure the institute will look into it. I request as a council member, and also I'll put in a word to the education committee to look into it. But such a wonderful, inspiring presentation. I do look forward to more inspiring stories by the next GCA on this side of the story, not on the technical, traditional actuarial side, but also stories around how we are coping up with what is happening on the tech side. Thank you so much. Thanks for the patience. And I let you go today. Be back tomorrow in time. And we look forward to an engaging session as usual. Tomorrow we have member IRDA coming over there to deliver a speech. Please be there. Thank you so much. And I leave it to the organizers.